What's up, home slices? This is Mr. Peterson here. We're going to be talking about complex numbers and roots today, and your learning goal should be to be able to define and use imaginary numbers. So let's just talk about a little bit of kind of vocab here. You might want to write some of this down. I'm going to talk over it. Imaginary numbers, this is kind of a little idea here. Imaginary unit is the letter I. And every time you see the letter I, you need to think it's the square root of -1. The square root of -1. And then the idea of an imaginary number is just the square root of a negative number. And it always has two parts. There's b and then I, and they're being multiplied together. The b is the real number, and the I, of course, is the imaginary unit, which is the square root of -1. We'll talk about why this idea of imaginary numbers is important when we get to class today, but right now let's just kind of look at some of the mechanics of working with them. So first up, we've got example 1a, which is 3 times the square root of -16. So we're taking the square root of a negative number, so that means we're going to have the imaginary unit in there. So another way to think of this is really just 3 times the square root of a -1 times a 16. 16, of course, is a perfect square. 16 is a perfect square. And of course, the square root of -1 is just the I. So we're going to pull both of these out, and then they're going to get multiplied by the 3. So what we really have is a 3 times a 4 times an I. So we have 12i as our answer. And that's our imaginary number right there. There's the b, which is 12, and then the I, which is the imaginary unit. All right, let's do this one over here. The opposite of, or negative square root of -75. All right, so when you think about the square root of 75, well, the square root of 75, we would have 25 as a factor, and then we could also pull out a -1 from that. So it's -1 times 25, and then 25 times 3 would get us back to that 75. All right, so if we're looking here, we have a perfect square here, which is going to be our 5, and then we have a -1, and we're taking the square root of it, so that's our I. The 3 is not going to get out from underneath the radical. So the I and the 5 are going to get multiplied by the negative out here, and if it helps you, you can think of that as like a -1. All right, so we have a -5i times the square root of 3 as our final answer. All right, why don't you guys try this one, and this one, and finally try this one. All right, let's look at solving a quadratic equation that has imaginary solutions. And again, we'll talk more about like what this really means and how this applies to quadratics when we get to class today. But here, let's just look at the mechanics of this so that we can kind of be masters of it in class. So this is the idea. We're going to use the square root property, take the square root of both sides. All right, so this is the square root of x squared would just be x is equal to, and then we would do the square root over here, -81. All right, so we need to notice that we could rewrite this as a -1 times, and 81 is a perfect square, so 9 times 9. So that 9 comes out in front. So x is equal to plus or minus, and then the I is a -1, 9i, plus or minus 9i. And now, just this once, let's go back and do a check. You guys always should do a check, but I know we want to make these videos as short as possible. But let's go back and do a check on this. All right, so we had two roots here, a positive 9i and a negative 9i. So let's check this idea of doing a 9i and then squaring it. And that should equal 81. So let's just see here. That would be, and just taking baby steps here, what this really means is 9 times 9 times I times I. All right, and this would be our 81. And then I times I, that is I squared. And so it's an I squared is a negative 1. So, and just to recap why I squared is a negative 1. I'm sorry, I guess I'm kind of jumping a couple different topics here, but if we have, remember I is equal to the square root of negative 1. So if we square that, if we square the square root of negative 1, it's just going to wind up becoming a negative 1, which is why this is really just 81 times a negative 1, which is what we were trying to get, negative 81. Oh man, I can't write when I'm down at the bottom of the board. Negative 81. That's supposed to be an equal sign, a gross equal sign, and that's what we were trying to get. All right, let's also check the other one though, because we could also, remember the answer was plus or minus 9i, so we could also do a negative 9i squared should equal 81. And then, so let's just look at what this would really mean. That's really a negative 9 times a negative 9 times an I times an I. And that would be a positive 81 and times an I squared equals 81. Remember, I squared is a negative 1. So 81 times a negative 1, it equals, well, it should have been negative over there, equals negative 81. Negative 81 equals negative 81. Both of those check out. All right, I'm going to erase that and go on to this one. So we have 3x squared plus 75 equals 0. So let's take our 75 away from both sides. So we get 3x squared is equal to negative 75. Divide by 2 on both sides. X squared is equal to, whoa, back up, Mr. Peterson. We don't want to divide by 2, we want to divide by 3. Divide by 3 on both sides. X squared is equal to negative 25. Take the square root of both sides. X is equal to the square root of negative 25, which is going to be a x is equal to plus or minus, and I'll just write this out here. This is the square root of negative 1 times 25. Square root of negative 1 is I. Square root of 25 is 25, so it's going to be 5i plus or minus 5i. You could do the check for that as well. All right, and then lastly, actually, why don't you try this example, and this one, and this one. And then lastly, we have this idea of a complex number. A complex number is a number that could be written in the form of a plus b times I. And in this situation, a is the real part. And we'll talk more about this in class today, but it's the real number part. And b times I, as you can imagine, is the imaginary number part. And then here's this kind of key idea here, is that two complex numbers are equal only if their real parts are equal and their imaginary parts are equal. And that ties into this idea right here, equating two complex numbers. All right, so we have 3x, take away 5i is equal to 6 minus 10y times I. All right, so remember our real parts have to be equal to our imaginary parts. So I'll do a little color coding here. This is real, and this is real, and this is imaginary, and this is imaginary. So our real parts have to be equal to each other. So 3x has to be equal to 6. So we divide by 3, divide by 3, x is equal to 2. And our imaginary parts also have to be equal. So a negative 5 is equal to a negative 10y. Divide both sides by negative 10. Negative divided by negative is a positive, so y is equal to 5/10, which is really just 1/2, positive 1/2. All right, so why don't you guys try this one and this one. And now I know we did a lot today that maybe it kind of doesn't make a lot of sense. We're going to hopefully put all this into perspective when we get into class and see how it works with quadratics. All right, we'll see you there.